These students are tasting ratio mixtures. How might they describe them mathematically? This video will focus on MGSE6 RP3A. Make tables of equivalent ratios, relating quantities with whole number measurements, finding missing values in the table, and plot the pairs of values on the coordinate plane. Use tables to compare ratios. Multiplicative relationships are first introduced in 4th grade. It is the first time students are required to distinguish between additive comparisons and multiplicative comparisons. In 5th grade, students are expected to interpret fractions as division of a numerator by a denominator, as well as solve word problems involving division of whole numbers resulting in fractions or mixed numbers. This connects to 6th grade ratio concepts such as students can view ratios as fractions and apply division to help determine the multiplicative relationship within ratios. Students develop the meaning of ratios and proportions using equivalent fractions. Students should be able to develop the concept of a ratio where the comparison is a part to whole. These concepts will be used to solve problems involving ratios. As specified in the standard, students work with whole number quantities. As students transfer their 6th grade knowledge to 7th grade, they should be able to compute unit rates of ratios with fractions, represent proportional relationships, and determine if relationships are proportional. They will also identify the constant of proportionality. One powerful way to demonstrate ratios concretely is by modeling equivalent ratios using a real-world example. Let's return to the students tasting 3 different mixtures. Watch as they use Cuisinart rods to model the ratio of water to chocolate mix from the following scenario. 1 cup of water with 4 teaspoons of hot chocolate mix, 2 cups of water with 8 teaspoons of hot chocolate mix, 1 cup of water with 2 teaspoons of hot chocolate. Alright, Carlos, so tell me what you have here, buddy.
So this is 2 cups, there's 2 yellows, big orange, so like that, and then there's 1 cup.
Students who label models significantly outperform students who do not. This is because labels give meaning to the quantities in abstract representations. Did you hear how the student attached the meaning to the orange and yellow rods? With visuals, students are often able to see the patterns created by the quantities. This standard requires students to transfer the data collected using the concrete models to a table. Just as students attach meaning to the concrete materials, labels are essential within the ratio tables. These students are using data from a card sort to create a table of equivalent ratios. As you listen, record the misconceptions which arise from this task. Feel free to pause the video or rewind to hear the students thinking.
Do this. Would you look at this? Do that. And then so we were to do that 2/3. It should be the one should go where the girls went, where the girls is. So there should be one where the girls is, and it's either 1/3.
Students who struggle with determining equivalent ratios will benefit from returning to concrete models to see the relationships. This student needed to see as the number of boys increased, the number of girls would need to increase in order for the ratios to be equivalent, as shown in this next student's work.
Six, and he's like he equals like 3 guys. I mean, isn't it every 2 girls for every 3 guys?
Yep.
So he's like 3 guys, and then if you do 2, it's like 1, 2.
The tables are useful when plotting the data on a coordinate grid. In this example, the student is plotting data from this table. Listen as they think out loud about the relationship of the table to the x and y axes.
1, 2. Wait, no, that's 0.
No, wait, hold on.
0. 1, 2, 3, 4. So every 4 minutes, yeah, 4 minutes, and 2 blocks. So now 10.
10 5. Alright, so 10 10 and then 5.
What conclusion can the students draw about the equivalent ratios in their graph? Eventually, students will connect the idea of equivalent ratios to proportional relationships in linear functions. The 3-act task Arcade Basketball Insanity can be found in the Georgia Department of Education 6th Grade Math Frameworks Unit 2. With this task, students apply the ratio table strategy to determine how many more shots the player made before time expired. Listen as the student uses her table to explain her thinking.
For sure.
45 seconds.
Wouldn't 34 be over here because...
No, I got it. I'm done.
No, but I'm saying, wouldn't 34 be right here because it's the ending? That would be 45 because it would be 6, 12, 18. At the bottom would be 15, 30, 45 because each shot 15. Where did 34 go if it's 34 seconds left? You can't do that in the table because each 15 shots is 6 seconds. So keep going. 15, 30, that's 12 seconds. Another 45, 18 seconds. So you can't put 34 in the table.
Well, can you extend the table?
Yes.
Yes.
Take a look at how this student is using the ratio table to make sense of the relationship between the quantities. According to John Vanderwall, instruction that focuses on reasoning rather than a formula can have an effect on a student's ability to reason proportionally, which begins early with multiplicative reasoning. Focusing on the procedure of finding the missing value in a proportion encourages students to apply rules without thinking and causes the stunting of their proportional reasoning ability. So what can we do as educators? Well, the progression document states it this way. Although it is traditional to move students quickly to solving proportions by setting up an equation, the standards do not require this method in 6th grade. There are a number of strategies for solving problems that involve ratios. As students become familiar with relationships among equivalent ratios, their strategies become increasingly abbreviated and efficient. It is important to avoid using cross multiplication when determining equivalent ratios, as it will undermine students' reasoning ability.